cryptocurrency and Bitcoin, and the topic that I shall be covering will be uh, uh, how actually money or cryptocurrency is used as a medium of exchange, and what are the issues. There's one typo here. What are the issues with centralized system, uh, centralized banking system, and then we'll see how we design a cryptocurrency and what are the mechanics of Bitcoin transaction, Bitcoin mining and consensus. So before I start the actual stuff, so these are the important books that somebody might have shared with you all. So the first book is Bitcoin and Cryptocurrency Technology. These authors have also given Coursera course, and this book is very nice. I'm having with me. It's a very easy-going book, and it's just to get an introduction of Bitcoin and how things are actually working. It is given here. And in the second book, Distributed Ledger Technology and the Science of Blockchain, again, this is a very nice book. If you want to appreciate the blockchain, the underlying framework, which is one of the most important framework for the success of Bitcoin is blockchain, and the science of blockchain, how blockchain works, the way it is working, and what are the shortcomings of this blockchain framework, you will find in this book. And Mastering Bitcoin, since in my slide I am covering Bitcoin, so some of the images I have taken from Mastering Bitcoin. And this Network Security book by Radia Polman is again very good one. You can go through. Now let us start with our actual stuff. So if you see the current transaction system, what we do is like there's a bank, and if customer A is transferring some coin to customer B, say 2, then this bank is having this ledger with themselves, and so 2 Bitcoin has been, you are transferring from account A to account B, so the balance of 2 becomes 0 and the balance of B becomes 9 after this transaction happens. So this ledger is with bank. And bank is the one who actually verifies your transaction, whether A is actually having 2 Bitcoin to be transferred to B, 2 Bitcoin or 2 rupees or $2, whatever you feel like. So your bank is the one who is actually taking care of this validity verification that sufficient balance is there in A's account, and he is maintaining the ledger with you. Now, what is the problem with this kind of banking system? The problem with this kind of banking system is only central body is holding the ledger. So all your SBI transaction which you are making, all transactions are with bank. Okay. So bank is holding all the ledger and you don't have any accessibility. Okay. If you want, you can get for 6 months, 1 year. But the problem is central authorities, like in theory, practically I am not telling that SBI and all these banks are doing, but they can do anything. They can falsify a transaction. Out of thin air, they can generate 100 rupee and they can assign it to LS, and it is there in their ledger. Okay. No one is there to stop him. There is no cryptography to give this protection to you. It is the bank. If he wish, he can do that. Again, if bank can change the transaction, so bank can change from Alice to Bob, instead of 1, 5 is transferred. So bank can change the old transaction. And the centralized solution, the problem with centralized solution is one entity records the data. So the bank is recording all your data, and he has a lot of power and responsibility. So since it is a single authority, they can fine you, they can reward you, they can enact fine, you might find it unfair, and they can declare NPA. So they are taking your money, giving loan to different agencies, and if agencies are defaulting, then they are declaring it to be NPA, non-performing asset. Now all these things are happening, and because of this, the first Bitcoin that started in 2008 was because of all these issues of like banking system failure, authority that they can issue a currency out of thin air, they can edit old transaction, they can make new transaction, they can delete your information, and there's only one copy of this ledger. So cryptocurrency started. So what is cryptocurrency? Cryptocurrency is again a medium of exchange using cryptography to secure the transaction and to control the creation of new unit. So like in our system in fiat currency, so this paper note is called fiat currency. So who is actually printing these notes? RBI is printing this note. So if you want to start a new currency, new cryptocurrency, then again you have to take care of how it will be created, how it will be distributed among participants, and then it will become a medium of exchange. Okay. So the main property that you wish to get out of cryptocurrency is there should be trust distribution, there should be verifiability, and there should be anonymity and traceability. What is these terms? We'll see. So a cryptocurrency is a digital or virtual currency that is meant to be a medium of exchange. It is just like a real world currency, but it does not have a physical embodiment. So you can use a cryptocurrency for medium of exchange, for purchasing goods, for store of value. So these days, people, at least in India, people are not using Bitcoin for transaction, but they are having a wallet and they are putting some Bitcoin in their wallet just as a store of a value. If price will increase, then they will make some money out of it because Bitcoin price changes very heavily. We'll see that. So they work in a decentralized manner and they are independent of bank. So cryptocurrency don't need any third party banking system who will verify the transaction and who will keep track of all your ledger. So there's no need of third party, and directly two party can participate in transaction. So new coins are added based on certain algorithms. Now the top 10 cryptocurrency based on market cap are Bitcoin, Ethereum. You can see these are the top 10 cryptocurrency. So Bitcoin, Ethereum, Bitcoin Cash has come out of Bitcoin only. And then there is a Litecoin, there's Monero, Zcash. There are many, more than 3,000 cryptocurrency are there. And every day you will find new cryptocurrency entering into a market. So what is Bitcoin? Actually, Bitcoin was created in 2008 and it is based on cryptography for integrity of ledger and for establishing the source of a. So if someone is having a money based on cryptography, we ensure that the money is with him. He is the one who actually owns that money. And once money changes hand, then again using cryptographic technique, we ensure that process also. So Bitcoin is one such cryptocurrency and it got the advantage of first mover. It is the first cryptocurrency and it is very heavily used these days. In most of the exchanges, you will find Bitcoin entries there. So any digital money without any central authority, what you expect it to be. So before designing a first cryptocurrency, so what you expect out of any cryptocurrency? So see, in our fiat currency, like paper note currency, what is the biggest issue? Fake currency. So the same thing might pop up in our cryptocurrency. So you have to be resistant with counterfeit currency. Okay, counterfeit fake currency, you have to be, it should be resistant to that. And there should be algorithm. It should be controlled supply of currency should be there. Because if you are having a lot of money in the market, then what will happen? There will be huge inflation. Am I right? And then it will unnecessarily lose its value. So the cryptocurrency in a system has to be generated by some algorithm. And it should be secure. It should be secure means there should not be any double spend. I will tell you what is double spend. There should be integrity in the ledger. Nobody should be able to forge a transaction. Nobody should be able to spend someone else's money, impersonating himself to be him. So all this security has to be ensured by this one. The first thing any cryptocurrency does is whatever is their ledger, financial transaction. For example, in transaction, so all ledgers maintain transaction by transaction. And so red customer is having 5 coin, he can distribute among red and blue. So all these transactions, what they do is they are flooded all across the globe. So they're all participant is decentralized and all transactions are shared among all parties. So there's no one bank who is having a ledger of all transactions. Here the transaction is shared among all participants. All stakeholders, they can have one copy of ledger. And so here comes the transparency. The first thing they did is, any cryptocurrency does is this, sharing of the all transactions. Any cryptocurrency, you expect three things, three main features from any cryptocurrency. First one, a blockchain. What is blockchain? We'll see what is blockchain. So simply you assume a blockchain is a data structure where all transactions, past transactions are recorded. Okay. And it stores the transaction. There are wallet. Wallet is something that keeps private key, your private key and public key. So in any public key cryptographic system, we have two pair of key. So private key and public key. So using private key, we can get public key. So they comes in pair. So if I encrypt with private key, I can decrypt with public key. Likewise, if you're putting a digital signature, if you're doing a digital signature, then with private key, you put your signature, and with public key, people will verify your signature. You must have studied digital signature. So it helps to keep track of cryptocurrency balance. We'll see how. And the third process is called mining. So mining is mining takes group of unconfirmed transactions and include them within a block in the blockchain. So what miner do? They will, from their transaction pool, they will pick a set of transaction. They will make a block and append to a blockchain. We'll see what are all these. things are. So the advantage of cryptocurrency is like without any third party, two party can directly participate in fund transfer, and they don't need any bank, they don't need any settlement authority, they don't need anyone to verify your transaction, and it is quick. It is quick. And what happens? The disadvantage of cryptocurrency, what people think is like, the cryptocurrency started with a Silk Route, a website where all illegal drugs and things were carried out through that website. And the owner of that website is now in USJ. So people started using cryptocurrency because cryptocurrency offers you anonymity, pseudo-anonymity, not complete anonymous, pseudo-anonymity, because all transactions are made with a public key address. So this public key address is transferring 2 Bitcoin to this public key address. So there is no identity mapped to a public key address. So it was very difficult to track that. Rakesh, in our bank, what is happening? We have our account number, but account number is mapped to your this one, our KYC, know your customer. Am I right? Our bank detail is mapped to our account number is mapped to our PAN card, address, everything. So this account number, who is the owner of this account number, you can be traced. But in cryptocurrency framework like Zcash, Monero, Bitcoin, what they ensure that identity is not the real identity. Identity will be 134 character hexadecimal value. Okay. So what will happen? All transaction will be made based on using that public key address. So it will be very difficult to map who this public key address is, but somehow they can profile you. Okay, this public key address is doing so many of transactions. That can be done. That is why it is pseudo-anonymous. And once you are having a Bitcoin currency, once you go to exchange, there you have to, for example, there are exchange where Bitcoin can be converted to your actually dollar, rupee. So there are exchange. There if you go, then you have to give your identity that you are the one who is having this one. And this is the way actually that gentleman was caught. So criticism of cryptocurrency is like it has got huge volatility in price. You will see Bitcoin price changes a lot. Okay. And because it is based on demand and supply, and so it changes a lot. And you will find the Bitcoin price shifted in December 2017. It was $19,000, and after 1 month it dropped to $7,000. So many economists feel that cryptocurrency are just a short-lived fad or speculative bubble, and it will vanish very soon. So even if cryptocurrency goes, the underlying framework, blockchain, is going to be here, and blockchain will be are being used for in research and giving a single ownership and checking and proof that this asset is owned by this guy and how actually assets are changing hands. You can use blockchain for these activities. So somehow this font got changed. I don't know, but I hope that it is readable. So now we'll design a cryptocurrency. Before designing a cryptocurrency, we'll see a background. So there are hash pointer. We know what is pointer. The pointer is a variable that holds a location of information. So hash pointer are the pointer where some information is stored. And apart from holding the address of information, it also holds the hash of the information. So that if any, so apart from fetching the value, you can also check whether the value has not been changed. And it looks like this way. So this is the hash pointer. So this is a hash pointer. So it holds the address of this data. Apart from address, it also holds hash of this data, so that it can fetch a value at this location, and also it can check it has not been modified. It has not been modified. And we can build many data structure using this hash pointer. The first data structure that we can build is blockchain. So what is blockchain? Just like linked list. Linked list, we put a data and there is a pointer. So again, this is a data and this is the pointer. Now this pointer is not a simple pointer that points to previous node. It also points to, apart from pointing to previous node, it also keeps hash of this node. Hash of this node is also stored here. So it is called a blockchain. It's a linked list with hash pointer. Here pointer will be replaced by a hash pointer. So now this is a hash pointer. It stores the address and hash of this value. And what is hashing? So hashing is a function for a variable length message, it gives you fixed size digital footprint. Fixed size digital footprint. Okay. Now, this blockchain is a data structure and it is tamper evident. This is tamper evident. It's a how this is tamper evident. So, what do you mean by tamper evident? Tamper evident means is this. See, if how we can detect. So the idea is like once we have a blockchain and we have a header of this list. Header of this is, remember, the value is remembered. Okay. Any adversary comes and he changes this data. If he changes this data, then this hash will change, won't match. This hash won't match because this hash is derived out of this data. Previous hash with data together, this has been derived. If I change any data here, then this hash won't match. In order to match this data hash, again you have to change this. Once you change this, again this hash won't match. Again you have to change this. Now once you change this, again you have to change this hash, but you cannot change this hash because this is what is being remembered. So what is the idea? Idea is blockchain is tamper evident log. What is log? Log is a data structure where all information I store it so that later on if I have to check anything, what happened at what time of time, we can confirm it. So blockchain is also used for tamper evident log. So in blockchain, if I remember this head of the block, if I remember the hash value, if anybody wants to change this, he will be caught because it won't be consistent. It won't be consistent. Let's take an example. Let us take an example that this is 5, this is 3. This is 5, this is 3. Now this is 8. Okay. And this is 5. This is 13. This is 2. And 50 is what he remembers. So in this setting, previous hash is 3, data is 5, 5 plus 3, 8. So let us assume that we are using hashing just simple addition, mathematical addition. So 5 plus 3 is 8, 5 plus 3 is 8. Oh, this should be 8 and this should be 5. This should be 5. Previous hash, 8, 5. Likewise, this should be 30, this should be 2. Okay. Now, in this setting, if I change 5 to 6, then what will happen? This becomes 9. But what is stored? 8 is stored here. It won't match. It won't match. Then in order to change this to 6, I have to change this to 9. Likewise, if I change this to 9, I have to change this to 14. Earlier it was 13. I have to change this to 14. And in order to make things consistent, I have to change this 15 to 16. This I cannot do. So if I remember somehow in this blockchain data structure, if somehow I remember this, then I can find that there was any editing, something has been tampered or not. We can find it. Likewise, a blockchain was a linked list with a hash pointer. Here we have a binary tree with a hash pointer is called Merkle tree. And the scientists who developed this called Ralph Merkle. And here what we do, all data will be leaf. All data will be in leaf. Okay. All data will be in leaf. We take pairwise data, and we take hash of this, hash of this, hash of this, hash of this. Now these two concatenated together, and then we take hash of this combined and put here. And if I remember the root of the tree, hash, then if anywhere I change, either in data or in hash value, it won't be consistent with root of the hash. So we can detect like this way. In Merkle tree also. And in this Merkle tree, as I have told you, it is hash of this, I concatenate this. Say we can use, so if I have to prove the membership in a Merkle tree, so what is this Merkle tree? All transactions are here. We take hash of them and concatenate together and then hash, and we move one level upward and we make a tree out of this and we remember this. Now in this tree, all transaction in a block, so a block consists of several transactions. So one Merkle tree is associated with one block. So what happens? We have like this way. We have a block. In blockchain, what we have a block, all transaction we write here and hash of this we put here. All transaction we write here, combined hash of this we put here. Okay. Now all this, it is stored like this way. Now what we can do, all transaction, how do I organize this transaction? We organize this transaction as a tree, in a form of tree. Okay. in form of tree, so that all data, all transaction is the leaf, and we combine this and we get a hash, and we put a hash of a tree here. The advantage of this is we can prove a membership. If I have to prove that this data is in this block, and how do I prove the membership? Very easy. If I have to prove that transaction TX2 exists in this block, then what I have to do? I have to give A, I have to give F, and I have to give root. With this 4 information, he can check the membership. Why? Because see, from my transaction data, the verifier party will get B, he can find B. Using A, B, he can find E. F already I have given. With these two, I should get a Merkle root. And I am getting the Merkle root which is saved. Yes, this transaction belongs to this. Because it is very difficult to forge two transactions that give the same Merkle root. Because of this collision resistance property. So the advantage of Merkle tree is like we can hold, a tree holds many items, but just need to remember the root hash and can verify membership in order of log and time and space. Now we'll design a cryptocurrency. So before designing cryptocurrency, these things we have to take care of. Who in our cryptocurrency system, just like fiat currency, who prints cryptocurrency? Who prints fiat currency? RBI. And then somehow it is dumped into the system, either some government project, road construction, some bank they will be giving to help them to get out of NPA. So they know how to distribute the printed money to different agencies. In our cryptocurrency, we have to decide how and who creates the new coin and how we take care of counterfeit currency. Okay. And once transaction is taking place, how we ensure that it is secure. And once transaction is, who owns the ledger, who updates the ledger. Okay. How transactions are organized in ledger and how we prevent double spend. These things are, we have to take care of in a cryptocurrency. Now before starting cryptocurrency, I would like to recall a digital signature. You must have studied today morning just to afresh. So we have a message, there is a hashing algorithm, and then we get a hash value. On this hash value, we apply a signature algorithm and we get digital signature. So along with the message, we have a digital signature. Okay, digital signature goes. Okay. So this is a message. This is a message. This is the message. And this is the digital signature. Okay. At the verifier side, how do I verify? How do I verify that it has come from the genuine user? So I will take your public key. I will take your public key. I will take your message. I will take your signature. Okay. If this gives me yes, if this gives me yes, then this message is coming from authentic user who is having a corresponding private key which is associated with this public key. Okay. What happens, you know, am I right? You have a message again. On message, you apply a hash function, and then on this signature, you decrypt with public key. You get a message H dash. You compare if H is equals to H dash, and then it is coming from authentic user. Because with the public key, I can decrypt a message M hash, and it was signed using the corresponding private key. So the person who is having the private key corresponding to this public key has sent this message. It is verified. Okay. Now we'll start with the design of the first cryptocurrency. It's called a Goofy coin. So who is Goofy coin? So Goofy coin is a person. There is a who actually creates a coin. Who creates a coin, and the coin which he creates belongs to him. So the simplest cryptocurrency we can think of is like that. Say a very recently singer Akon is going to start his cryptocurrency. So whatever cryptocurrency is started, that whoever has started that belongs to him. And then somehow he will distribute that currency by airdrop, or there are ways out, and he will give that cryptocurrency to different customers. So now customer will start using this cryptocurrency as a medium of exchange. So let us assume that there is a Goofy. Goofy is the one who started this cryptocurrency. So the first rule of this cryptocurrency says that this cryptocurrency which we are designing is like whatever coin Goofy is creating. So all created coin will have a unique coin ID, and it will be signed by Goofy. It will be signed by Goofy because Goofy is the one who is owning the system. He will sign it, and this coin belongs to Goofy. Now, Goofy, if he wants to pay this money, so our money is represented by this data structure. So this is the money, create a coin function with a unique coin ID. So this is the coin which is created. It is signed by Goofy. So this says this is the coin which is created by Goofy. Yes, Goofy can create and he has signed. So this is the authentic coin because it is the signed copy. Now, if Goofy is taking some service from Alice. Now, for getting a service, he have a pay to Alice. He is paying this money. What money? So this is a hash pointer. So I want to pay to Alice the money which I have owned here, which belongs to me, okay? Which belongs to me, and I am giving this money to Alice for certain service, and this is signed by Goofy. So money can change hand, and see how using public key cryptography digital signature, money is changing hand. So you can verify it. So now Alice can say that I own this money. How? Because he will show this. From this it can be seen, oh, this is signed by Goofy. Means Goofy has given money to him. Which money? So this money. This money, oh, Goofy has created this money with this coin ID and he has signed this. Yes, legitimate user. Alice is the legitimate user of this coin. Now Alice will take a service from Bob and he can give likewise the money to Bob. Now the problem is double spend. Goofy can give, Alice can give the same coin to Alice and Bob and Chuck. See, it is correct. So he has given money to Bob. Bob can verify the money which he is giving is this. Yes, it belongs to Alice. And now from where Alice got? Alice got from Goofy. And from Goofy got, oh, he created this coin. He is the owner of this coin. So now Alice is the owner of this coin and now Bob is the owner of this coin. Now likewise, Chuck is also correct. Chuck is also owner of this coin, finding via this path. Now this is double spend. This you don't expect. See, once you have a 50 rupee note in your hand, you cannot double spend. But in digital currency, you can make n number of copy. Am I right? So the dollar which you have, you make n copy of that dollar and send to all your friends. Okay. So double spending is very easy. So one of the biggest problem with any digital currency is double spend. So this Goofy coin is not good. This Goofy coin is not good because it suffers from a security problem of double spend. Now we'll move on to a Scrooge coin. Now the second cryptocurrency which we are designing is Scrooge coin. So how Scrooge coin works? So Scrooge coin, what he will do, whatever transaction is happening, he will put in a ledger, blockchain, and he will publish onto a public platform. And whatever is the hash of the head, he will sign it. Scrooge will sign it. So everybody is trusting a Scrooge. So Scrooge will never cheat. So Scrooge will write all these transactions in the ledger, and all these ledger are chained in the form of blockchain. And whatever is the header of whatever the hash value of this, it will be signed by Scrooge. So anybody can verify that this is legitimate, this is consistent, and this is signed by Scrooge. So now, if Alice tries to send the same money to Bob and Chuck, she will be caught because Alice transaction will be here. So Alice has given money to Bob. Now, if Alice tries to give the same money to Bob here in this transaction, Bob here, it won't be written here. It won't be written here by either Scrooge or Scrooge won't, and Chuck will also won't accept. Bob also won't accept because Bob knows that this money already Alice has given to Bob. You get my point? Once a ledger is public, all transactions are public. Alice has given her money, the money which she owns to Bob. She cannot give the same money to Chuck. Why? Chuck can see from the ledger, the distributed ledger, public platform ledger, that this transaction with this sequence number is already there. So double spending problem is solved. Here. So rather than having one transaction, we have all transaction like in the form of Merkle tree. The hash of this root is stored here. Okay, so we can do this optimization, and the hash of this head will be signed by Scrooge. Now this is the secure system. How secure system? Nobody can change, because if you change this, then this has to be changed. All this blockchain is tamper evident. Okay, you cannot change this header because this header has been signed by Scrooge. People are trusting Scrooge. So double spending problem is solved, and Scrooge is generating money. Now how money is actually created? Who is creating money here? So there are two types of transaction in this cryptocurrency. which is owned by Scrooge. Scrooge creates a coin. So in this transaction ID 73 and transaction type is create coin. In this transaction, Scrooge is creating a coin of different value, and who are the recipient? Recipient are these public address. This public address. So Scrooge has created in this transaction 73 3 coins of serial number 012 of value 3.2, 1.4, 7.1, and he has made these guys as a recipient. These are the recipient of this coin. So he is the one who is starting a cryptocurrency, Scrooge, and he is creating a coin and giving to different recipient. So this coin will be known by this ID. Coin ID 73 parent 0. This coin will be known by 73 parent 1. This coin will be known by 73 parent 2. Okay. So two type of transactions are there in this Scrooge coin. One is create coin transaction, and the second one is pay coin transaction. In pay coin transaction, what we are doing is this. First, we write in this transaction what are the values which are getting consumed. Okay. So our transaction consumes and destroys some coin and creates a new coin of the same value. So these coins are consumed 68, 142, like 100 rupee note, 200, 500 rupee note, 20 rupee note. So the way we consume actually in our fiat market, am I right? We have different currency and you cannot, it is immutable. You cannot tear it. 100 rupee coin, you cannot tear it. 50 rupee, you cannot make it. It is used in an intact way. Am I right? Likewise, here also a currency will be used, consumed and destroyed, and a new currency is created. New currency is created with a number 0, 1, 2, and if 68 one currency I am consuming here, he has to put signature that he is okay with the transaction here. He is ready that in this transaction his coin is getting consumed. So this pay coin transaction in our Scrooge coin is valid if consumed coins are valid. Means 68 one, the 68 one I should not consume in 2-3 times. That should not be a double spend. Okay. So Scrooge coin has to ensure from his ledger that 68 one, wherever 68 one is there in the output, 68 one in the output is there, that whoever was the beneficiary, the first time he is spending here. Say for example, Bob got 68 1, 42 0, 72 3 somewhere in previous transaction. Now he is spending in this transaction, Bob. Okay. Now Bob should spend 68 1 only once. He should not spend 68 one coin more than one time. Then there will be double spending. Scrooge is taking care of all these things. Okay. So this transaction is valid by according to Scrooge if consumed coins are valid. If these coins are valid. Not already consumed. These coins are not already consumed. And the total value of these coins is same as this. Okay. And it is signed by the owner of the coin. Then this transaction is valid. And this is an immutable coin. So what is happening? This is a Scrooge coin. So we started with a Goofy. In a Goofy coin, there was a problem of double spending. Then in this Scrooge coin, what we have is all transaction which is happening, we put in our public ledger. So the ledger, it is transparent to everyone. If you try to do double spend, you will be caught. Okay. Now who is generating a coin here? Scrooge. He is creating a coin, and there are two types of transaction here: create coin transaction and pay coin transaction. Okay. Now the biggest problem is, so here double spending problem is solved, most of the problems solved only, and here also there is immutability, nobody can change the ledger, okay, and all transactions are transparent, it is in ledger. But the problem is, earlier we had a bank, now we have a Scrooge, he is the one who is actually managing everything, so there's a huge reliability on Scrooge. Someday if Scrooge says, no, I won't give service anymore, then your system will fail. Scrooge is not giving service to Alice. Scrooge is not entering any of the Alice transaction. Then what will happen? Scrooge may one day say that for all transaction I will charge some money. So now we have to de-Scroogify this currency. Now it is very much centralized. We have to make it decentralized. And now comes the Bitcoin. In Bitcoin, all these things were decentralized. And how it is decentralized? Let's see. Okay. So Bitcoin, the first classical paper by this gentleman, nobody knows he actually exists or not, Satoshi Nakamoto. He gave this paper in 2008, I think, in a cryptography mail list. And this paper talked about like how we can have an electronic transaction system in peer-to-peer framework, okay, without any trusted middleman. So there is no need of bank. And this paper was published. This paper was published in 2008 when there was a huge financial crisis. All bank collapsed. That Lehman Bank collapsed, and so the first the block which was added into the blockchain, he wrote in his there's a field for text that a chancellor on the brink of second bailout for bank. So people were very much angry. So people were thinking of some alternative, that there is a huge reliance on banking system. So this paper was published in 2008 and its source code was available in January 2009. And the first transaction was made on 3rd January 2009. And so it is assumed that Satoshi Nakamoto, whatever is the pseudo name, whoever this person is, he is responsible for writing this paper, and he is also responsible for writing maximum code of Bitcoin. Bitcoin client and Bitcoin core, everything, most of the coding, the base coding he has done. Now there is Bitcoin.org Foundation. They keep this update of this framework. Any coding, anything required changes, and Bitcoin.org, it's a forum. They are actually taking care of this Bitcoin framework now. But most of the coding was done by this Satoshi Nakamoto. And if you see, Bitcoin market is more than $300+ billion. Okay, and its price varies a lot. 2 days back, its price was $19,000, more than $90,000 for one Bitcoin. And Bitcoin face, nobody knows. Bitcoin network is a peer-to-peer network. Peer-to-peer network. Like in client server, there is a server node, and all client node request for a service from a service node, and service node gives service to client node. Here in peer-to-peer node, all these nodes are interconnected, and they share their resource among each other to achieve a common goal, and they don't need any centralized administrative body. So it looks like this way. Okay, and in Bitcoin network there are 4 types of nodes: wallet, miner, full blockchain, and routing node. So wallet, basically we have a software wallet where our where a transaction is signed by wallet, public key, private key, he will keep for you. Miner are responsible for all transaction. Miner will club and make a block and add into a blockchain. So miner are actually responsible for adding block to a blockchain. And there's a full blockchain node. These nodes, they have entire blockchain right from the beginning to end. They have this. There are networking node. So some nodes are called resilient client, Bitcoin core node. They do everything. They behave as a wallet, they behave as a miner, they behave as a routing node, they behave as a full blockchain. So these Bitcoin core node, they have everything. They are wallet, they behave as a wallet, miner, blockchain, everything. So these are the type of nodes in a blockchain network: reference client, full blockchain node, solo miner, lightweight, SPV wallet. Okay. So Bitcoin peer-to-peer network is, it runs on a TCP port number 833, and so how it works? It works like this way. Let me show you the slide. So can you see the slide now? I have maximized this one. Mayank sir, slide is visible now?
Visible, sir, visible.
So in Bitcoin peer-to-peer network, what is happening is, like, once you are the node who want to join this Bitcoin peer-to-peer network, see 8 is the node, he wish to join to a Bitcoin peer-to-peer network, then there are certain seed nodes. So all Bitcoin client, Bitcoin node, in their code, there will be certain seed node. They are managed by Bitcoin.org framework, and they are always on most of the time. So you can talk to seed node and get address. So I am asking, who are all your neighbor? So I will say 1 and 7 is my neighbor. Then I talk to them and I say, who are all your neighbor? And then I'm having some idea of overlay network. So somehow 8 has positioned in this Bitcoin network, he has joined. Now if any transaction happens at any node, transaction, I will show you how transaction happens in the wallet. So if any transaction happens from A to B, so this is flooded. This is flooded across all nodes. So everybody, all node will have this transaction information. Likewise, all transaction which is happening, it will be flooded. Okay, and then a transaction pool will be prepared by all nodes. Out of these transaction pool, miner will be the node who will be responsible for taking out certain transaction from transaction pool, make a block, and he will append it to a blockchain. We'll see that in a coming slide. So So what happens? So what these nodes will do? So this node will relay a transaction only when transaction is valid. And if they matches, the script matches with whitelist. We'll see what is that whitelist and what is that script. And this has not been seen before, because once it has been forwarded, A to B has been forwarded, then again the same transaction won't be forwarded. It's a flooding kind of thing. So once I have flooded, the same won't be flooded again. Okay. So there are chances of race condition. I won't trouble you here. In consensus, we'll see that. So typically what happens? New transactions are broadcasted to all nodes. We'll see in consensus again. And so this is called flooding. Some node will collect new transaction into a block, and in each round a random node gets to broadcast this block. So what is happening? All transaction will happen. It will be broadcasted. Everybody will know what transaction has happened. And there will be some node called miner. They will group this transaction into a block and append to a blockchain. So what is happening? So there are so what happens in blockchain? There are blocks. So already there are block there. So miner will find a new block. Miner will find a new block and will append to this blockchain, extend this blockchain. So how they will find that is there are algorithm protocol for that, but somehow they will find a block, they will add it. Okay, and they will be actually checking. They will again check the validity of all these transactions. Now in Bitcoin, there is a notion of public key identity. So what the first key property of Bitcoin is? It is pseudonymous. What is pseudonymous? So, like in banking, our account number is mapped to our name, address, PAN card, everything. But in Bitcoin, each entity will be known by his public key. Public key. So, for every public key, there is a private key. These two comes in pair. In public key cryptography, public key, private key comes in pair. So, with one I can encrypt, with another I can decrypt. And here it is based on elliptic curve digital signature algorithm, ECDSA. Okay. So, there are different digital signature algorithms that you can do. So here Bitcoin uses ECDSA. So there is a notion of public key and private key, and it has nothing to do with your real world identity. So my Rakesh has nothing to do. So I can generate. So my wallet create this public key, private key. They are open source software, OpenSSL. There you can create n number of public key, private key, your ID. So creating your ID is very easy in Bitcoin. And why we have one of the biggest requirement of Bitcoin is anonymity. And there's no central authority to give you ID also. Who will map this Rakesh is this public key address? So there's no central authority mapping our ID to this public key. And so what happens actually, our public key becomes identity in Bitcoin framework. And what is public key? How do I understand public key? So see, there's a message. I'm signing that message, and my public key, if this verification function gives you true, what it means? It means that this message was signed by someone who is having private key corresponding to this public key. Okay? Who is having private key corresponding to this public key. So I can say that PK says this message. So I'm mapping an identity. So I can mapping identity to a public key. Okay? And I can generate any number of public key, private key pair. So identity in Bitcoin, if you see, this is the address, it is the hash of a public key, and how actually we generate a public key, we'll see that. So the Bitcoin address looks like this way. In wallet, Bitcoin address looks like this way. Okay, this is our account number. So once you have to transfer your money, so this is the in your wallet. If you have to in your wallet, there will be address will look like this way. So if anybody wants to transfer your money, you give this address, Bitcoin address. Bitcoin address is derived out of a public key, and this is the signing key. It is kept secret. It is kept secret. Signing key. Okay. Now we'll see how we have how we generate a Bitcoin address out of a private key. See what happens in Bitcoin is based on elliptic curve cryptography or elliptic curve digital signature algorithm. In elliptic curve, there is a point called G. There is a point called generator. So private key, I will choose a random number K and I will multiply with KG. Now it's a point multiplication. KG becomes public key. KG becomes public key. It's a point multiplication. K is my private key. I will never tell my private key K to anyone, but KG is public. And once KG is public, nobody can know this K. It's very difficult to find K. It's a discrete block problem. So this public key, I do double hash, SHA-256. SHA-256 is a hashing algorithm, and output is 256 bit. Again, the output of this, I fed it into RIPE-MD 160. So full form is written here. It produces 160 bit output. Okay. Now this is called public key hash. This is called public key hash. Okay. And then this is 1 byte of, I add a prefix. So what kind of address we are trying to generate? If it is pay to public key hash, then we put 00. If it is pay to public key script, then it is something else. So just for understanding, it is 00 I have appended. Now these two together, I double hash it. And then whatever we get, it's a 256-bit string, binary string. First 32-bit I take and put it this as a trailer. And under base 58 encoding, I get a Bitcoin address. So what I am telling, so the idea is from a public key, I can get a Bitcoin address. Okay. So for a private key, from private key, I generated a public key, and from public key, I generated a Bitcoin address, and all are linked. All are linked. This is what you are supposed to know, that I can generate a Bitcoin address from public key. Okay. Second key property of Bitcoin is decentralization. Decentralization means that it has a ledger but no bank, and the ledger is agreed upon and distributed among many entities. And the ledger is the blockchain in Bitcoin. So many entities having this blockchain. So blockchain looks like this way. Blockchain looks like this way. So this is block 0, block 1, block 2. All transactions are written here. Hash of this will be also written here. Actual blockchain will see that. Okay. So we have a ledger, and the ledger will also, if Alice is sending money to Bob, so Alice is signing that I am sending the virtual currency 1 of serial number 1 to public key B. So this is written here. So on the same ledger, what happens if Alice tries to give the same money to Mary? Then what will happen? It will be caught from the ledger. He will verify the same money which he is transferring to me is already mentioned here. So you can, double spending can be stopped. Now, Bitcoin transaction. So we have seen that in Bitcoin, there is a distributed ledger, there is a blockchain, and that the same blockchain is distributed among all participants. And now we'll see Bitcoin transaction, how transaction looks like. So there is something called account-based ledger. So typically in our household, this is what we do. We have so we can have a 25 coin. It is credited to Alice and it is generated. Okay. Now from 17 coin from Alice to Bob, and Alice is sent. Okay. Now 8 coin is getting transferred. So all these are transactions. And in our ledger, we are appending one transaction, second transaction, third transaction, fourth transaction. Am I right? This is what we do in our household diary. Am I right? Whatever transaction is happening, we write it. Now, the problem with this kind of setting is account-based ledger is like, now Alice wants to send 15 Bitcoin, 15 rupee to David. Now, how do I ensure that Alice is having 15 Bitcoin? I have to move backward and check where Alice is beneficiary. Alice has received something, and then we have to subtract whatever Alice already spent. If it is more than 50, then this is valid, transaction is valid. So in ledger-based system, this is the overhead. Either we have to move backward or we have to maintain a separate data structure for all account balance. This is what bank does. For all balance account, a balance is maintained. So a lot of bookkeeping has to be done. Bitcoin don't go with this account-based ledger. What Bitcoin does is, it is called transaction-based ledger. So what happens? Every transaction, so this is the transaction number one. In every transaction, we specify two things, input. So in this transaction, what we are spending, I get from where, and the output, the money whom I am giving. So this is 25 Bitcoin I am giving to Alice, and input is, so here somehow the currency is getting created. So here currency has been created and 25 coin I have given to Alice. So currency is created in this transaction. 25 Bitcoin has been given to Alice. Now, in the second transaction, what is the input? Input is transaction number 1 and index 0. Okay. So this transaction is spending the money which he received in previous transaction number 1 and index 0. Okay. So he received 25. And 25 money, now he is spending to 17 on Bob, and 8 he is keeping change with himself. This is called transaction-based ledger. In transaction-based ledger, in every transaction, in the input we have to specify the money which we are spending in this transaction, I got from where. So it should have a reference to previous transaction output. So it is having in input, I have a reference to previous transaction output. Okay. And output is, I'm giving 17 to Bob and 8 to Alice. Okay. So likewise, in transaction number 3, input is I have to make previous reference to previous transaction 2, 0. So this is transaction number 2 and index 0. This is index 0, and if I have to spend this, then it should be index 1, 2, 1. Okay. So every transaction in the input I have to specify the previous transaction reference where I am the beneficiary. Okay. So Bob is spending a money which he got in transaction number 2, index 0. He got in transaction number 2, index 0. Yes, Bob got. Now this money is 70. He is paying 8 to Carol and 9 to keeping with himself to Bob. And this transaction is signed by Bob. Okay, this is valid. It can be verified using your hash pointer. Hash pointer will point to this transaction 2, 1. Am I right? And you can go to that block. You can see that this much money is there and you can work it out. Okay. You can work it out. And Bob is having the money. This money belongs to Bob and he is putting his signature. Now, how do I check whether the money which he is spending here, the money which he is spending 2, 1 has not been double spent? 2, 1. So I go to 2, 1. I go to 2, 1 transaction. And from there onward, we come to this transaction and see anywhere 2, 1 is there in input. If it is there, then this is a double spend. So we can check. We can move backward from there. We can check it, or we can have a separate data structure where all unspent transaction output, we can keep it. It is called UTXO. All unspent transaction output. So I maintain a log of all transaction output that has not been spent yet. So this is called a transaction based ledger, and Bitcoin follow this. We'll see how actually Bitcoin does this. We'll see that. And this is implemented using hash pointer. Okay. Now you can use this to merge different value also. For example, we can merge these two. So Bob is the beneficiary here. So in a transaction 1, 0. So this is 1, 0. Okay. And 2, 1. Okay. And these two together is merged into 90. Bob is signed by Bob. So I can merge it. I can merge 2 money into 1 if I am the owner. Okay. Joint payment also can be done. So Carol and Bob together, they will put signature in a transaction and they will sign and they will give this to be a 6 plus 2, 8 to David. Okay. For simplification here, we are showing 1 transaction per block, but actually in Bitcoin, more than 1 transaction happens and 2 signatures are there. If you see Bitcoin wallet, so Bitcoin transaction is done through a software. So Bitcoin exists as a software and transactions are conducted through wallet app, and wallet creation generates a Bitcoin address. It looks like this way. So wallet looks like this way. So here I enter say 1 Bitcoin. So to this address, if I want to send money to this address. So this is your friend's wallet, and if you want to scan, you can scan by this. Scanning is okay. Typing is very difficult. You might commit a mistake. If you commit a mistake, money is gone, then you won't be getting that money back. So you write this Bitcoin address here. You write how many Bitcoin you want to transfer. Its equivalent US dollar will be here. Okay. And then you press continue. Okay. And it can be done. Okay. So this is your Bitcoin, from your wallet, it will be transferred. So unspent transaction output, I have told you for every transaction output, I store somewhere, so that everywhere in any transaction in input we give reference to previous transaction output. Am I right? So we keep in one location. Okay. So transaction, if you see, I've told you in any transaction I take an input from previous transaction, and then we have output 0.1 I give to, and there is a transaction fee. So whatever is the input minus output, whatever is the output, that becomes the transaction fee. So I have told you that miner actually makes a block out of this from transaction pool and append to a blockchain ledger. So he gets this transaction fee. He will be getting this transaction fee. Okay. So how it happens? It happens like this way. In input, we give reference to previous transaction output. In input, we give reference to previous transaction output, and then we spend. This is what actually happens in Bitcoin. We'll see one example. Real Bitcoin transaction, if you see, it looks like this way. So this is the metadata. This is the transaction. This is the transaction ID, the hash. This is the version number. So in this transaction, we are having reference to input. So there are two input. This is the input number 1. Okay. And this is the input number 2. And this is the output. It says, and it is of length this. It is of length this. So in input, there is a reference to previous transaction. So previous transaction hash, previous transaction ID this. It's a hash of that transaction. And index 0. In output, index 0, the money I am spending here. Okay. And this is the response. This is the response. I will tell you what is this response. Response to the challenge. Response to the challenge. I will tell you what is this response. And the second in input, the second previous transaction reference, index 0. Again, this is the response. And the money I want to transfer, this much of money I want to transfer to this. Here I am not writing a transfer money to this public key address. We are not doing this. We are telling that money will be transferred to someone whose challenge script is this. Challenge script is this. And he has to give response. And this can be spent. This money can be spent by someone if he gives suitable response to this challenge. Suitable response to this challenge. And this is the response. So he want to spend this. He want to spend this. So this is the previous transaction reference. Okay. At index 0. So I am consuming this coin, Bitcoin, this Bitcoin, and I am sending 10 Bitcoin to someone who with this script. Rather than giving address, we give script. It will be clear to you. Very soon it will be clear to you. It will be very soon it will be clear to you. So these are the two inputs are there. One output is there. Data size 104 byte. And this is the index of previous transaction output. Index to previous transaction output. And hash of previous transaction is this. And this is the input script. Signature to redeem the previous transaction output. So this is the response that we have. In order to redeem this, value, whatever money was given in this transaction output, in order to redeem it, I have to give this suitable signature, script signature. Okay, what is this? Incoming side will be clear. And I am telling that this money can be spent by someone with output script this. Okay, and type of script is script public. Okay, what is happening? What is happening? So this is already I have told you. What is this? So this is the output. What it says that this is the signature, and so in input, this is the transaction and this is this one. Already I have told you. Now in output, this money can be spent only by a party whose public key hash is this, and who is able to give suitable response to this challenge. This money will be consumed by a person whose public key hash is this, and who gives suitable response to this challenge. What is suitable response? We'll see. Now, before that, we'll see Bitcoin script, because here we are not writing that give $10 to this public key hash. We are not writing give this public key hash or public key address. We are not writing directly like this way, but it is based on a scripting language. So what is scripting? So scripting. Bitcoin scripting language is based on script. It is called as script. It is derived from 4. So it is a very simple language. There is no for loop. It is simple, compact, and it supports instruction for cryptography. There are special instructions for hashing and for signature verification. It is a stack-based language. What is a stack-based language? In stack-based language, we have two kind of instruction, either data or opcode. So if instruction is data, then it is pushed onto the stack. And if it is opcode, then this opcode operation is performed onto the top of stack data. If this operation is binary operation, then I pop 2 elements from the top of the stack. If it is unary operation, then I pop only single element out of the stack. And he is Alan Turing. This language is not Turing complete because you cannot write complex function. So there are special opcode do, opcode hash 160, op equal verify, op check sig, op check multisig. So op dupe is a method opcode that duplicates the top item on the stack. Op 160, it does the hashing of twice. So it will pop the topmost element and will do twice hashing. So these are all opcode. So this opcode will pop top element and duplicate and push onto the stack. op hash 160, he will pop top element, he will do double hash and push onto the stack. Op equal verify, and so Bitcoin script consists of 256 opcode, and so opcode are for arithmetic, if then, logic. Now let us take a fiat currency, fiat money transfer, how it takes place. So typically in fiat money, if Alice wants to transfer money to Bob as a birthday gift, then actually the transaction should be logged like this way. So I am giving analogy of how Bitcoin does and how in fiat we are doing. So in input, in transaction A, at index 1, whatever I got, $40, that I am spending. In Bitcoin transaction, imagine in fiat currency, if we keep this kind of record, then how much transparent it would have been. Am I right? So in every transfer, I am telling this money I am spending, I got from this transaction. Okay. And $20 I am giving to Bob and 20 to LS. Likewise, once I am transferring in transaction B at index 1, whatever money I am having, that I am spending, I am giving 4 to Charlie and remaining to LS. This is the fiat money transfer which takes place. Am I right? However, you don't keep track of from where you got this money, but this is the way actually you exchange. But see how actually Bitcoin transaction. This is very important. This slide is very important. So how Bitcoin transaction takes place? It takes place like this way. So see what happens. Alice, Bob, and Charlie, they have their wallet with them. So wallet, I have shown you the diagram of that wallet. There are many wallets. These are all software available, third-party software. So wallet have a private key of Alice, and from private key there is a public key. Okay. Let me change the color. Now, public key and public key hash and Bitcoin address. So wallet has all these things. Now, somehow, if in transfer ABC, from whatever input he got, output he say, output is written like this way. Output Bitcoin address. So Alice wants Alice wallet, from his wallet, he wants to send 40 Bitcoin to Bob. So in address field, what he will write? He will write the Bitcoin address of B. Bitcoin in address field, he will write Bitcoin address. Okay. I have shown you that transfer address field. You have to write the Bitcoin address. This is that Bitcoin address. Now, I give a challenge. I write a script. I don't simply write that you send this $40 to this Bitcoin address. No, I give a challenge script. What the challenge script says? It says op duplicate, op hash 160, and I write public key hash of B. Public key hash of B. This I write. This I write here. And op equal verify and op checks it. These two are opcode in scripting line. Now Bob, if you want to spend this, if he want to, Bob is the beneficiary of this because he is having this Bitcoin address. Now Bob, if he want to spend this, in input he has to write, he has to make in input the reference to previous transaction ABC. Let us change the color. Let us change the color. So ABC is making, so this is the transaction. In this transaction, I want to spend money which I got in output 1. This is the 1. I got 1 and he is giving the response. So who can spend this money? A person, Bob can spend this money only when for this challenge he gives suitable response. What is suitable response? Let's see. He will give a signature. He will give a signature and public key of B. Public key of B is this. He gives public key of Bob, and how he will calculate signature? He will compute signature on this message, on this message, on this message, on this message, on this message. He will do SHA-256, SHA-256. He will encrypt with its own private key, with its own private key. See, its own private key. Encrypt whatever signature he gets, he will be writing it. What it means? It means that this 40 Bitcoin, this 40 Bitcoin can be spent by someone whose public key hash is this, and also he is having corresponding private key with that public key, corresponding to that public key. We'll see that, don't worry. So what is happening? I say that this transaction is valid. So if anyone has to verify this transaction, what he will do? He will append this script, signature public key B, and this script one after. So this one he will write and two he will write, and he will execute 1 and 2 on a stack. So this is 1, this is 1, and this is 2. This is 2. So Bob can, so this is a Bob. So what is happening? Alice has given money to Bob in his output Bitcoin address to Bob, and this is the challenge. This is the response. Bob can only spend this money if he gives suitable response. And what is that suitable response? We'll see. So what he did, he gave a public key of B. Before that, he gave signature. Signature was computed on this message. On this transaction, ABC1, this is the address. So he's sending Bitcoin to C of amount 20, and this is the challenge to Charlie. Charlie can spend if he give a suitable response against this. Now, I'm not reading any message actually. So if you are writing any chat message, I'm not reading. In the end, we'll take it. So in a stack-based language, what we'll do? Signature is pushed onto a stack, then public key. What I told you, all data is pushed onto the stack, and opcode will perform operation. So signature is a data, I push onto a stack. Public key is again a data, I push onto a stack. And then op duplicate. Op duplicate will pop the topmost element public key and will duplicate it. Public key gets duplicated. Op hash. Now 4th step, he will pop the topmost element public key and will make public key hash. Now this is the public key hash of public key provided by Bob. And Alice says that whoever public key hashes to this, he can use it. So this is the recipient public key hash which Alice wants. So this is what will be pushed here. This will be pushed here. Public key of the recipient. And then you verify that the public key hash, which the hash of this public key provided by Bob should match with the challenge. Challenge में output में say कि the money can be spent by someone whose public key hash is this. These two should match. These two, if it matches, then yes, Bob is having a public key whose hash is this. Okay. Now apart from public key, so anybody can have. Apart from public key hash, his signature also should match. So when signature match, then okay, Bob is the actual Bob because he's having private key corresponding to that public key. Okay, if you want me to repeat, please tell me. If you want to repeat, you tell me. Okay. You have an input script and output script combined together. It is called script sig, it's called script pub key. And then you can do this verification onto a stack based language. Okay, stack based. I'll be answering this question. This is the way actually it works. So we have an object multi-sig kind of thing, where you have a support like this transaction output can be consumed if out of k out of n signs the signature, then also it is valid. Okay. So there is a notion of proof of burn. So there is an option that you can write something permanently onto a blockchain. So, but whatever money you have spent in input, that will be lost. You won't be getting that. What you have to do is like op return, this method you have to call. Whatever arbitrary data you write there, it will be permanently returned to the blockchain. Nothing will be redeemed because in output because output will be returned from here. So nobody will be the beneficiary here. Okay. And you can use this Bitcoin transaction for escrow transaction. So in escrow, what we do is like, I will come back if time permits, then we'll be doing this escrow and green address. Let us do our this one. So what we have in Blockchain Explorer, the transaction looks like this way. So this is the transaction, this is the hash of the transaction, and the input to the transaction, you have a previous reference to the transaction. So in previous reference to the transaction is this transaction hash, and I am sending money to this Bitcoin address, these two Bitcoin address. It is still unconfirmed because it is not written onto the blockchain. Okay. So this is the transaction ID. This is the input address. This is the output address. Okay. And then total input output, you can see this. And this is unconfirmed. Input index. So input, we have previous transaction, this one and this. You can see the PK script and script say. So now we'll move on to a Bitcoin consensus, this one. happens in Bitcoin, what is happening actually? See, in a Bitcoin peer-to-peer system, when Alice wants to pay to a bar, then she broadcasts the transaction to all Bitcoin node. Okay, and what transaction he transfers? You have a pay to public key bar. So he's telling pay to, and the money which I got, this is the hash pointer and this is signed by Alice. And this is flooded to all node. Okay, there are miners. Miners responsible for storing ledger. They relay the transaction. They verify transaction that this transaction is legal. It has not been forced. Okay, and it also participate in the consensus. Why would anyone choose to do this to become miner? Because they are rewarded. They are rewarded. And how consensus algorithm works? So new transactions are broadcast to all nodes, and you follow a flooding protocol. We have seen that flooding. So there are some nodes called miner. They collect all these transactions and make a block out of it. And this block is, and this miner are chosen randomly, and then they add block to a blockchain. And what is that randomness? We'll see that. So Bitcoin consensus. So why? So what is this consensus actually? See, consensus is a phenomena where in a distributed database system, for consistency, you want to have same state should be there. Okay. In Bitcoin also you want the notion of a ledger. Everybody should have the same notion of ledger. Am I right? So the blockchain, the order of transaction should be same on all sides. But it is very difficult to get onto a in a distributed system, getting a stick. It is many standard algorithms are there that shows that in a synchronous or asynchronous, getting strict, consistency is very difficult. It's very difficult. So in theory, in practice, Bitcoin works very good. There's a weaker notion of consistency here, weaker notion of consensus here. We won't be entering into algorithm part. We'll see how actually it works. So miners store ledger, relay transaction, and they are rewarded. So it is based on this. What it does is see, miner, what they do is this. Wait. Automatically slide is going on. Okay. So what happens? There is a concept of proof of work. So what is proof of work? In order to show that some work you have input. So so this was used in older this one. If you want to get an email service, then the email server is giving you some work to do, and you do that work, then your mail will be forwarded, just to throttle spamming. Okay. So what it says, it says that for a given message, what X I should append so that the hash I get starts with 30. So I have to do certain computation. So in your output sample space, there are 32 different possible chances. And what is the favorable? Favorable is 4. Am I right? 1, 2, 3, 4. 2 keep power 5. 2, 4, 16 or 32. Am I right? 32 chances are there, or 16. So there are 32 possible chances, and you want it to start with 30. It start with 30. So 4 by 32, 1 by 8 chance. So if I do a hashing, I try one number, I choose any number 1. Then what is the probability that I get a hash that starts with 000? It's 1/8. So in worst case, you have to try 8 times, 2 keep power 3 times. Worst case, so that you get a hash, so that you get an X that gives a hash starting with 30. What happens in a blockchain? See, there are miners. They have a pool of transaction. And they have a blockchain. Let us assume that this is the blockchain. And miner will take out of this, he will take certain transaction, and on this transaction, he will make a block. Now he can add a block to this blockchain only when, if he is able to find a nonce such that hash of this block, and all transaction hash, and plus I choose a nonce in such a way that hash of all this will give a value that starts with this many 0, or that is less than this target. You're getting my point? What is happening? So already blocks are there in your blockchain. Everybody is having. So this is miner 1, miner 2, miner 3. Everybody is having the same notion of this blockchain is visible to M1, M2, M3. And they have their transaction pool. Out of this transaction pool, everybody will make a block. He will also make a block. He will also make a block. Why? Because making a block, once a block is written, once his block is written onto a blockchain, then what will happen? He will get a money. He will get a reward for that. And how and whose block will be written? It is decided by who find this solution first. What solution? So if I am extending this blockchain, so whatever is the hash of this block, this hash and hash of the transaction which I am taking for my proposed block, all hash of the transaction, and I choose a nonce in such a way, this is what I can change. And I take hash of this all together, then I should get a number less than target. Whoever solve this nonce first, whoever find this nonce first, either this minor, this minor, he will be able to extend the chain. He will be able to extend the chain. And once his block is written, then he will get reward, block reward. Okay. So this is what, so minor j, if you want to extend this block I plus 2, he will take hash of block I plus 2, concatenate with hash of all transaction. So he will have 6.2 is the block reward. He will get transaction fee for all transaction. He will take, he will put in a block and hash of this, and he will choose a random nonce such that it starts with 30. So somehow if say this gives a hash of this starts with 30, so he has won. So he can add this block onto this blockchain, and he will get 6.25 block Bitcoin. Okay. So this is the way actually we get. So how actually proof of work works? Let us see. So this is the real header. This is the real header, and I want a hash. I want a hash that starts with 30. So I start with 30. If I start with 30, then hash of previous this, hash of this gives me this. But what is my expectation? My hash should start with 000 something. Okay. Then again I have to try 1. Once I do 1, I get some other hash. Then I do 2. So I have to keep on changing a nonce so that I get the desired this one. So if all these are, if all I try, I did not get something starting with 0, then I change here. Then I change in Coinbase. So there's a special transaction where a miner adds a block reward for himself. It's called Coinbase. I add 1. So this hash will change. This hash will change. So, okay, this Merkle root will change. Merkle root will change. Again, I start with 00. Am I right? So what we are doing? We are simply trying to find a nonce. Which nonce? We are trying to find this nonce. This nonce. This nonce. This nonce. So that previous block hash, current block, whatever transaction I am adding, which I want to extend to. For example, this block I want to add. All transaction which I want to put here, its hash. And I have to find a nonce so that it gets less than the difficulty. Okay. So this is the way actually you have this is a special type of transaction called Coinbase transaction that I add into a blockchain, and it looks like this way. Previous transaction input is 0 because this is where actually so whenever a block is added into a blockchain, then only new coins are minted. So this slide is telling 25.5. So every time a block is added to a blockchain, 25 Bitcoin is added. Now 6.25 is the blockchain value. 6.25. Okay. So a special transaction is added in a block, and its input is previous hash, nothing, and nothing. Coinbase, here I can write my comment, and in output I say that this is the transaction fee, and this is the block reward fee, and this is the transaction fee. So 25 was 2 years back, 5 years back. Now it is 6.25. So all miner whose block is written onto a blockchain, he will get a block reward of 6.25. So this is the type. So this is what we do. So we do a hash of nonce, previous block hash, all transaction, and this is called the target space. If target space, this is the search space. If target space is small, they have to put lot of effort. Okay. Okay. Let us see what else we can do, because we have less time. We don't need this. Okay. Let us see in summary how actually it works. So what happens? There are transactions. These transactions are flooded. And all miners, they will have their transaction pool with themselves. They will have this transaction pool. From this transaction pool, they will choose set of transaction, and this transaction hash plus whatever ledger information they have, based on that, they would like to, if they want to extend this block, then they will use hash of this block plus hash of all this transaction plus non, it should be less than a target. So they try to solve a hash puzzle. This is also called proof of work. Okay. So different miner in different round, different miner will win, and the probability that a miner wins depends upon what percentage of hash power he is having, what percentage of hash power a miner has divided by total hash power. Probability that a miner won, a miner block is added onto a blockchain depends upon what fraction of hash power he is having. Okay, what fraction upon total hash power. Okay, and this is the proof of work he will do, and once he will find the block, he will flood that block to everyone, so everybody will know that he is extending this block. So he will verify the transaction, and next, if someone else has to extend, then he will extend from there. So you get two, this one, you can do here this one. So you get two reward, block reward and this. So some things we have to miss. You get a block reward and transaction fee. So why miner behave honestly? So miner behave honestly because they get block reward. And how money is generated in a Bitcoin? The person who adds block onto a blockchain, he get block reward, and that is the only way. So in Bitcoin, who generates money? Who generates Bitcoin? Bitcoin is generated by miner. Who are all miner? Miner are the node who are solving the hash puzzle, and whoever solves hash puzzle first, his block gets added onto a blockchain, and there is one catch also, and then he gets that block reward, and through block reward new money are added into a blockchain. Bank sir, do we have time, or I should wind up?
Sir, as per your convenience.
Okay, so
5 more minutes, I think.
Okay, 5 more minutes, we'll wind up. So you have your Bitcoin, this one reward is halving every year. You can see half, it is getting half every year. Okay, so there's a fixed supply of Bitcoin will be there, 21 million. Okay, so we won't be doing this, and there are certain game theory also there. So okay, from my side it is done. Some mining difficulty we can do. So last topic we'll do is mining difficulty. Mining difficulty, it says like on average you ensure that one block is added every 10 minutes. So what happens? Your mining difficulty depends upon a fixed value constant is there, n divided by target. And so takeaway point is you set your target in such a way. So for example, if you have to find a hash that starts with 30, okay, a hash that starts with 30 ABC, then in worst case, how many try you have to do? 1 by 2 to the power 3, because every position you get either 0 1 0 1, or if it is hexadecimal, then 1 by 2 to the power 4. Am I right? 4 to the power 3. So every places can have 4 different value. So how many? And you want 0 0 0. So first place can have 4 different values, second place can have 4 different values, third place can have 4 different values, and you want all 0. So 1 by 4 to the power 3. Am I right? Now difficulty. So if I increase the difficulty, means I say you find the hash of your previous block plus nonce plus current transaction, it should start with 50. Now 50 in hexadecimal. Then worst case you have to try 4 to the power 5. You have to try more time. So this is the way. If more hash are there, if many people are involved in mining, then hashing difficulty increases. So that you have to try more computation. More computation is required, because you have to maintain on average 10 block has to be 1 block has to be added every 10 minutes. And this mining difficulty is adjusted after addition of every 2016 block. Okay, it is again adjusted after 2016 block. This is the formula. There is no need. But the takeaway point is like you cannot have. This is the drawback of Bitcoin. You get less throughput, because after every 10 minutes you have 1 megabyte of block size, and each transaction is of 200 kilobyte. So only you get few number of transaction in your system. But PayPal, and so you have a scalability issue, throughput issue in Bitcoin actually. Okay, because and why you are doing this? because there will be unnecessary forking there. If you don't do this, then unnecessary forking will be there. System won't be optimized, and there will be a lot of chaos. So that is why this is maintained like this way. So Mastering Bitcoin book is there. Very nice book. Very easy going. 250 pages are there. You can go through that book. And in the beginning also I have given one more book by this one, Arvind Narayana, Bitcoin and Cryptocurrency Technology. You can go through that also. If you have any question, I'll be happy to answer. I know I was a bit fast, but okay. So I'm done from my side, sir. If anyone has
Thank
any
you.
question to ask, then.
Thank you.